Hola, mi nombre es Claudia Cortés del Distrito Escolar de Brownsville, Texas, y esto es NASA Ahora.
What that does on the asteroid, the astronauts read out the gravitational effect of those planets.
Hey, I'm Kristen, and this is NASA Now. As human beings push further and further into space, it is critical to understand the challenges and changes the human body experiences in a microgravity environment. Our expert today will examine the physiology of astronauts on board the International Space Station and share what scientists have learned. That's ahead. First, here's what's happening at NASA Now.
Taking another step towards deep space exploration. In the spring of 2015, NASA astronaut Scott Kelly and Russian cosmonaut Mikhail Kornienko will embark on a remarkable journey. The two astronauts are scheduled to launch aboard the Russian Soyuz spacecraft to the International Space Station. Here they will carry out a 12-month mission in space, the longest ever on the International Space Station. Data from this special mission will be used to develop ways to help reduce some of the risks associated with long-duration space missions, including bone and muscle loss, decreased cardiovascular function, vision changes, and decreased sensory motor performance. This information will help NASA prepare and plan future missions to the Moon, to an asteroid, and eventually to Mars.
The International Space Station Medical Project is responsible for implementing science experiments for NASA's Human Research Program in low Earth orbit. As the lead of a team that consists of engineers, planners, procedure writers, and science support personnel, Dr. Liz Warren has a big responsibility to ensure successful science in orbit. An extremely important area of study for the project is the effect of microgravity and ways in which humans may benefit here on Earth from what we learn in space.
Physiology is the study of living things. Now, it's a little bit different than biology because physiology goes a little bit more in depth to the structure and function of living things and how systems work together. For example, how the heart works with the lungs and how the muscles work with the bones. I work for the Human Research Program. The Human Research Program conducts research and develops technologies that allow humans to travel safely and productively in the space environment. When human beings live in space, their bodies change a lot. And the longer they live in space, the more changes occur. Bones can lose up to 2% of their density, and thus their strength, every month that they're in space. There's a misconception that bone is just kind of like dead tissue and it's just hard like wood, but that's not entirely the case. Bone is a living thing. There are cells in our bones that are responsible for producing blood cells, red cells and white cells. The bone provides protection from our inner organs, like our brain. You've got a skull to protect your brain. You've got a rib cage to protect your inner organs. It provides structure so that we can stand and move. Our bones also provide a storage for calcium, magnesium, and phosphorus. These minerals and blood and cells are constantly flowing in and out of the bone. Osteoporosis is a diseased state of bone in which the bone gets weaker and thus more prone to fracture and breaking. When osteoporosis occurs and the bones get weaker, all of those things are less effective. Now, if we can figure out how to prevent osteoporosis in space, we can apply that knowledge here on the ground. Another effect of living in space is a fluid shift. Our bodies on Earth have evolved and developed systems to keep blood flowing up to our brain. It's very important to keep blood up to our brain, and that's actually quite challenging for our cardiovascular system because it constantly has to fight against gravity. Think about the distance that a single drop of blood has to travel to go from your toe all the way to your head. It's a lot, and it is actually a lot of work to move fluid around your body. When you live in space, And without gravity, it's much easier to move fluid around your body. But your body is going to continuously try to push fluid up to your upper body. The result of living in space and this fluid shift together means that your upper body gets too much fluid. And you can see it in the astronauts' faces. They look a little puffy. NASA has been launching human beings to space for 50 years. And we've learned a lot about what happens to human bodies in space. If astronauts exercise up to 2 hours a day and they eat right, so their nutrition is very carefully monitored, we can prevent a lot of those changes from happening. Now, we can't prevent them entirely, but we can help to prevent them and continue to learn about why they're happening.
Did you know that a technology initially developed from space technology is helping us communicate right here on Earth? This portable and inflatable ground-based satellite communications antenna was used following Hurricane Katrina in 2005 and the Haiti earthquake in 2010. During both events, Gator, or ground-to-air transmit and receive, connected the survivors and first responders with the outside world when phone lines were knocked out and cell phone service was unavailable. This technology is now being used worldwide to provide communications tools to disaster relief and military personnel and to assist in the search for missing persons. Now you know.
Our expert, Dr. Warren, talked about some of the physical changes astronauts experience in space. Here's a way you can put yourself to the test right here on Earth.
Teachers, your students can experience changes to the human body just like the astronauts. Look for Human Body Space Adaptations. You'll find it by checking out the extension activity for this program on the NASA Explorer School's virtual campus.
Well, that's it for NASA Now. Be sure to visit our Facebook page and leave a comment. We'll see you next time on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer School.